So today we'll be doing from question number 16 to 20. Right. So look at this, the 16th question. A particle of mass m performs a simple harmonic motion with the maximum velocity and the maximum acceleration of the particle are v and a respectively. The angular frequency omega of the particle is given by. Right. If this is the oscillatory center O, and if I'm considering the particle is at a position of x from the oscillatory center, I can write the characteristic equation of simple harmonic motion as acceleration is equal to minus omega squared x. You know that. Suppose now simple harmonic motion is performed like this above the oscillatory center. It's going like this and coming like this, right? The maximum displacement from the oscillatory center, I can call it as the positive amplitude plus a. And here also I can have another amplitude which is negative, right? Right. So here, can you see that acceleration goes to maximum when the displacement from the oscillatory center is maximum? So acceleration is equal to what? Minus omega squared times the amplitude a. Maximum velocity v is equal to a omega. You know that. Then if I'm considering magnitudes, I don't need the sign, right? So look at this. I can take this as equation 1, equation 2. What will happen if I divide equation 1 by equation 2? I get a divided by v, which is equal to what? Omega. So what's the angular frequency then? Equal to, angular frequency is equal to what? Acceleration, maximum acceleration to maximum velocity. Right, let's come to, that question was very easy. Let's come to the 17th question from the potentiometer. It's an okay question. It's not a very hard question, but a good question. Right, a doable one. Right, let's see. 17th question. So I just give you the representation of the potentiometer. So this is E0, and it doesn't have any resistance. R is 0, but I have resistance R here, right? Okay, and I have the potentiometer via like so. Right. Okay, so I have the battery here. I'm not representing the galvanometer. You should, but I'm not. And I'm just, my primary motive is solving the question. So let's mark the balance length as L. Right. The entire length I'm going to take as capital L. Alright, listen. Right, can you see the entire potential difference of E0 is divided across R and across the resistance of the potentiometer wire, which is 10 ohms. So across R and 10 ohms, the entire potential difference of E0 is divided, right? So what do you mean by the potential difference per unit length? That's K. So potential difference per unit length means the potential difference, let's call it V, potential difference V across the potentiometer wire divided by the length of the potentiometer wire. That clear? If I divide the potential difference across the potentiometer wire by the entire length of the potentiometer wire, I get the potential difference per unit length across the potentiometer wire. Right. How can I find the potential difference per unit length across the potentiometer wire? How can I do that? This is how we should do it. You know the potential difference across the resistance R and 10 ohms, right? You know the potential difference across resistance R and 10 ohms. If you know the potential difference across resistance R and 10 ohms, then you can find the potential difference across 10 ohms, right? So now we can find the potential difference across 10 ohms because you know what is there across R and 10 ohms. So the potential difference across R and 10 ohms is E0. So if I divide E0 by R plus 10 and multiply it by 10 ohms, I get the potential difference across what? 10 ohms. Or you can think like this. E0 divided by R plus 10 ohms is equal to the current. So I found the current essentially. So current is equal to what? The current flowing in the circuit across this one. The current is going individually in this circuit like this. The current is equal to what? E0 divided by R plus 10. If the current is E0 divided by R plus 10, if I multiply the current by the resistance of the potentiometer, I get the potential difference across the potentiometer wire. So if I found the potential difference across the potentiometer wire, and if I divide that by the entire length of the potentiometer wire, I get the value of K. That clear? That means the potential difference per unit length. If I multiply the potential difference per unit length by the length I'm considering, which is the balance length, if I multiply the potential difference per unit length by the balance length, what do I get? I get the value of the unknown EMF E. Is that clear? Because potential difference per unit length times L gives you the potential difference here. This potential difference here is equal to what? The potential difference here, which is what? The potential difference of the battery, which is E. Now I got a general equation. Look at this. Let's consider the first occasion where they say the resistance R is 70, and the next instant where they say resistance R is 80. Look at this. All right, it's a very easy question. Just take it simply, don't complicate it. Right, look at this. Right, so E naught divided by what? R. Now what is R? When resistance is 70, 70. And then I have 10. So 70 plus 10. Right, times 10 divided by the length L. What's the balance length initially? They say the initial balance length is equal to how much? Yeah, 280, right? 280, right? 280. Okay, and this is equal to what? E. That's it. Is equal to E. Right. On the second occasion, what can you say? So I simplify this now. 70 plus 10 gives you 80. Right. So we have 80 here. Right. So this is the first occasion. In the second occasion, resistance goes to 80. Right. The resistance goes to 80 in the second occasion. Then what can you say? E naught divided by 80. That doesn't become 80. Now E naught divided by what? 10 plus 80. Resistance is 80 now. So I should what? Add 80 to this 10. Is that clear? This is a general equation now to this. E naught divided by what? 80 plus 10 now, no? Then I get what? 90. Is that clear? So I get 90 down. Times what? 10 divided by the entire length L. And the unknown balance length is going to be what? L. That is called unknown balance length as L. That should be equal to what? The EMF E. Is that clear? So if I take this as equation 2 and this as equation 1, what can I do? I can make equation 1 equal to equation 2 because both equations have the same term E. So what's going to happen now? I'm going to make these two equations equal. Then what's going to happen? Yeah. Erase this part. Right. Let's simplify this now. Now can you see, now I want you all to be smart. Can you see E naught times 10 divided by L is a constant? E naught times 10 divided by L is also a constant here. Then I can represent that by capital K. Right, I can represent that by capital K. Then what can I say? Capital K times the unknown length L divided by 90 should be equal to what? Capital K represents what? E naught, L and 10 is equal to what? Capital K times 280 divided by 80. Is that clear? Right, then I get what? 0, 0 cancels. Then I get 28 divided by 8 times 90. So L, simple L is equal to what? Simple L is equal to 28 divided by 8 times 90. Right, how can I simplify this? 28 by 8 is what? 14 divided by 4. 14 divided by 4 is what? 7 divided by 2. So 7 divided by 2 times 90. So 7 divided by 2 times 90. What is 7 times 9? 630. 7 times 90 is what? 630. 630 divided by 2 is what? 315. So I get the length to be what? 315. That is the balanced length that I get when the resistance is 80 ohms. But they are asking in the question not that. What are they asking in the question? By what distance should the sliding key J must be moved from the previous position to balance again if R is changed to 80 ohms? Earlier what was my balance length? 280. Now what's my balance length? 315. So by how much should I move? 20 plus 15, which is 35 centimeters. So I should move by what? 35 centimeters. I hope it's clear. It's a very easy question. Right. Now let's come to the next question. Right? Okay, so we have the 18th question. Logical inputs A, B, and C of the given circuit is shown below. Right. So you can see something like this. Try it out. Given the time that I give you now, you can try it out. And you can pause the video and try the question, whatever you like, right? What matters is whether you are doing the work in the class itself, right? Okay, so logical inputs A, B, and C of the given circuit is shown below. So what's the circuit? So I have this AND gate here, A, B, and I have the OR gate here. And the OR gate here, right? Okay. And this is the input C. This is the output X. So output is X. Right. What can you see? Can you see this? What does the AND gate do? Multiplication. If only A is 1 and B is 1, do I get 1 here? Is that clear? If only A is 1 and B is 1, I get 1 here. If either of the inputs are going to be 0, let's say A is 1 and B is 0, then definitely the output is 0. So I should definitely have A1 and B1 to get an output 1 here. What does the OR gate do? If one of the inputs is 1, output is going to be 1. If both inputs are 1, 1. If both inputs are not 1, which is 0, if both inputs are 0, the output is 0. That's a function of the OR gate. It's very clear, right? Can you understand or think logically? Right? If C is 1, right? Think with me together. If C is 1, I don't have to care about whom? A and B, right? If C is 1, I don't have to care about A and B. The output is definitely going to be 1. Is that clear? If C is 0, I have to definitely care about A and B. Is that clear? If C is 0, I have to definitely care about what? A and B. Because if C is 1, if this 0, it's going to be 1. If this is 1, it's going to be 1. If C is 1, this is 1, 1. If C is 1, this is 0, 1. Right? If C is 0, I should definitely think about this to see if it's 1 or 0. Right? If C is 1, I don't have to think like that. Now look at the occasion where C is 0. Definitely A and B should be 1 to get an output of 1, right? If C is 0, if this is 1 only, the output is 1. Then definitely for this to be 1, A should be 1 and B should be 1. So in the graphs, you can understand. Look at the occasion where C is 0. Look at the graph together with me. When C is 0, only when A is 1 and B is 1 should I get the output to be 1. Then can you see the cycle should be like what? The output should be like what? This. Because can you see when, now if you look at the graph in the second diagram, in the middle region, B is continuously 1, but A goes from 1 to 0, 1 to 0. Only when A is 1, can you see? Only when A is 1, when C is 0, I should get what? An output of 1. Is that clear? So think about this again. Right? And when C is 1, I don't care. When C is 1, definitely the output is 1. But when C is 0, definitely A should be 1 and B should be 1 to get an output of 1. But can you see, whatever that happens to A should happen to the output, because A is going to be deciding the output. Is that clear? A is going to be the decisive factor of the output, because only when A is 1, right? Because B is already 1 now. Only when A is 1, I get the output of what? 1. Just think about this. So the answer is going to be the second one. So whatever that happens to A happens to the output. Right? Look at the 19th question now. Look at the 19th one. The combined object illustrated in the figure is formed by joining four metallic rings A, B, and C of radii R, 2R, 3R respectively, made of some uniform wire. The distances to the center of gravity of the combined object from point X is. So I'm not going to represent the rings now. I don't have to. So I can say the center of gravity of C is here. So I'm going to represent C with a dot. And the distance now, you know that the radius of C is 2R. So I can say C is here. This is C. Right? But what about the mass of C? Right? Let's see. If this is a uniform ring, I can say that the mass is proportional to the length. Right? Mass is proportional to the length. So if suppose I have a ring and I'm going to stretch it out into wire, then you know the length of this thing is going to be 2 pi r, right? Then mass per unit length is the same because they are made up of the same material, right? They are made up of the same material. If they are made up of the same material, can you see their mass per unit length is the same? Then their mass is proportional to what? The radius. Actually, so mass per unit length is what? Mass per unit length is same. Let's call it simple m naught. Mass per unit length is simple m naught. If I multiply the mass per unit length by the entire length of the ring, I get the total mass of the ring. So can you see the mass of the ring is proportional to what? The radius of the ring? I hope it's clear. Right. Then taking this idea into consideration, what can you say? Look at C. If you look at C, the radius of C, you can see the ring in the diagram, the radius of C is 2r. Then the mass of C should be 2m. 2m, right? Okay, on this left side, I have what? A small ring. The small ring has what? I'll draw a better diagram. Sorry. Right, I have this point X and then I have C, right? So center of mass, center of gravity is here, right? Center of gravity is here. And the distance to the center of gravity of C is 2r, right? And the mass of C is 2m. We know that because the radius is 2r, because I said mass is proportional to radius. On the left side, I have what? A. The radius of A is r, therefore the mass is m. But the distance from A to the point X is going to be how much? Yeah, r. Okay, and then we have B. B has a radius of what? 2r. Therefore the distance from B to that point is also going to be 2r. Okay? And then I have D. Radius is 3r, so this is going to be what? 3r from D. So this is D, this is A, this is B. A, B, D, and this is C. What's the mass of A? M. What's the mass of B? 2m. What's the mass of D? 3m, because it's proportional to the radius. And this distance is going to be 3r. Right. Now, if you take moments about point X, the individual moments created by the individual masses, by the mass 2m of C, 2m of B, m of A, 3m of D, if I calculate the individual moments, right, about the point X, the activity, the action of these individual moments should be shown alone by the moment of the center of gravity of the system. So can you remember that? So what's the moment created by 2m of C? What's the moment created by C in this direction, right? What about the moments created by A, B, and D? They're in this direction, the opposite. So the moment created by A, B, C, and D should be shown alone by the center of gravity. Then we can find the position of center of gravity from point X. So listen, so I can say what? 2m times the distance is what? 2r is the moment created by C, for example. Right. Now we know the moment created on this side should be greater than the moment created on this side. Okay, so I'm going to take moments in this direction. Right, what can I say? 3m times total distance 3r plus what? 2m times the total distance what? 2r plus what? M times the distance from point x, r, minus 2m times 2r. I take minus 2m times 2r because it's not in my direction. My direction is this direction, but the moment created by c is in this direction, about the point x. This should be equal to what? The moment created alone by the center of gravity. What's the total mass? 3m plus 2m plus m plus 2m. So you get 4m, then 5m, 8m. So 8m times the unknown distance x. That's clear? Times the unknown distance x. So this is the moment created by the center of gravity about point x. Then m, r, everything cancels off. Sorry, r doesn't cancel off. Sorry. Right? R remains the same. Right. But m cancels off. Then you get what? 9r here plus what? Can you see these two terms cancel? Right? Look at this. These two terms cancel. This term cancels off with what? This term. Then I have what? 9r plus r, which gives you what? 10r. So 10r is equal to what? 8x. Then I get 10r divided by 8 is equal to x. So what is x equal to? 5r divided by 4. I hope you understood this. Okay? Right. So here's the 20th question. Water and coconut oil are poured into the two limbs of a U-tube, as shown in the figure. Assume that the water-oil interface is at the middle of the tube and it's vertical. So the water oil interface at the middle of the tube is vertical. Rho watt is the density of water, right? And rho naught is the density of coconut oil. Consider the following expressions about this situation. All right, what can you say? Draw a diagram like this. So we have H3 here and H4 here. And we have P here and Q there. Alright. And we have H1 here. And we have what? H2 here. Alright. Atmospheric pressure is acting like this. Let's call it P. Right. So this is a different liquid. I symbolize like this. It's actually water. This is oil. Right. What can you say? Pressure at point P is equal to pressure at point Q. What do you say? Yeah, it has to definitely be equal. If the pressure at point P is greater than point Q, it's pushed in this direction. As this point is in equilibrium, as this interface is in equilibrium, pressure at point P should be equal to pressure at point Q. So pressure at point P is equal to pressure at point Q definitely, otherwise this interface won't be an equilibrium. Actually, it's at equilibrium, it's at rest. Therefore, pressure at point P should be equal to pressure at point Q. Right. Second statement, H1 rho W is equal to H2 rho naught. It's correct, yeah. Look at this. What's the pressure at this point P? Equal to atmospheric pressure P plus what? H1 rho water G hydrostatic pressure. I have to add the atmospheric pressure to the hydrostatic pressure to find the pressure P here. You know that pressure P is equal to pressure Q. Then that should be equal to what? Pressure at Q. What's pressure at Q equal to? Atmospheric pressure P plus what? H2 rho oil G. This entire length has certain pressure. That pressure should be added to the atmospheric pressure. This pressure here should be equal to this pressure here. Then these two are equal. Then I can say what? H1 rho water is equal to what? H2 rho oil. Is that clear? H1 raw water is equal to what? H2 raw. Right. Next one. Let's see. Third expression. But normally children get this wrong because they have not really understood it. Third expression. Now can you see, you need to look at this line. You can see the line here. If you look at this line, in this line, if I look at the left side, look at this point here in this line. This point belongs to water. This point belongs to oil. So have you heard of this expression? At the same horizontal level, pressures are equal. That is only true for the same liquid which is at rest. That's clear? For the same liquid which is at rest. So if you have heights like this, right? You've heard this idea that pressure, if the pressure at point A and pressure at point B. This is point A, right? And this is point B. The pressure at A is equal to pressure at B in the same horizontal level only if I consider the same liquid which is at rest. But can you see this point and these two, these 2 points, let's call this point 1 and this as point 2. Points 1 and 2 are in the same horizontal level, but they don't belong to the same liquid. They belong to 2 different liquids. Therefore, we cannot equal the pressures at point 1 and 2 and then write equations. That's why the third statement is wrong. So we can't say H3 rho W is equal to what? H4 rho naught. That clear? So what's the answer then? Only A and B is true. Right. See you in the next video.